Okay, so as we continue along in our adventure, I just wanted to show you this is what we're going to build. We're working on building this right now, and things are going to start moving quite a bit faster now that we've uh, done some things. We've learned how to navigate things. We learned about right dragging. We learned about scroll button dragging. We learned about scroll wheel zooming in and out, and we learned how to use um, the navigation cube to find things. So now what we're going to do is we're going to start making some sub-assemblies. I just wanted to, in my brain, I am thinking about how to build this robot, and I'm realizing, hey, I've got some motors down here that are going to have bevel gears and things. So we're going to do that right now. That's the first thing we're going to do. And then we're going to create some sub-assemblies, and then we're going to bolt this whole thing together. So we should end up with a robot base pretty quickly. So that's what it's going to look like. Let's get started right away. All right. From our previous lesson, we've got this quad block sitting here, and we're going to add some things. Okay. So insert other documents. And remember, if OSK23 library isn't there, hit OSK23, open the library, okay? And so there are part studios and there are assemblies. I think we demonstrated that a little earlier. This time we're going to go to assemblies. And there's this thing called a yellow jacket motor. You're going to click on that once and bring it out here. There we go. And now I'm going to left click that. And there we go. There is a go build a yellow jacket motor. Cool. It turns out that in order for us to use that bevel gear thing, we need to add a couple of bushings, and you'll see why in a sec. That's sort of a design thing. We're more interested in the mechanics of this. I have now come back over and clicked on Part Studios, and I need to add a spacer bushing, and that is this 1522 part. So I'm going to click that, and I'm going to pop it here. So there's my 1522 part, and I actually need 3 spacers, but we're going to do just one for now. 2807. It's just a few parts down. There it is. And I need one of those. So those are the parts I'm going to start with. And I'm going to hit, I will hit the green check mark. If you want to stop right now, go open up OSK23 library, insert a yellow jacket motor out of assemblies, and then you want to find 1522, insert one of those, and 2807, insert one of those. Go for it. Go do that. Okay, so now you've done that. I'm going to hit the green check mark. Now it turns out that part of the design, I know that I need to have 3 of these. And so I can click it once to select it. You can see it got highlighted up here, and you can see I've selected one item. I can right click now on that item, and I can do a copy. So there's a copy. And I come down, I'm going to left click once, that deselects everything. And then I'm going to right click, and you should see a paste available. Okay. So there, I pasted it. Very cool. Now I could have also highlighted this thing and did a Control C and a Control V. I'm going to do that right now. Control C, and here comes a Control V. So now I have 3 of those. That's exactly what I wanted. So we're happy. The idea is that this is going to form a stack of bushings. So it needs to be 13.5 millimeters is how long it needs to be. So each one of these is about 0.5 millimeters. So we're going to stack these up and then stack this on top of those 3. And then we're going to attach that over here. Here's how we're going to do that. We're going to, I'm scroll wheel dragging to slide things around. I'm scroll wheel turning to zoom in a little bit. And we're going to do a fastened mate. Okay, the fastened mate, I'm going to select that surface right there. And I would like to fasten that to this surface right here. Now, a little debugging is needed right off the bat. And this is super common. So I'm going to move this over a little bit. You can, one of these has disappeared. They're still over here in the instance list, and they're actually here. It's just that one has now been stacked on top of the other, and they shared the same axes, and so the one is actually inside the other one. To fix that, super common, come over here, hit flip primary axis, and now you can see the other part, right? So that is, again, happens all the time, no problem. I'm gonna hit the green check mark, okay? Now I need to do another fasten to mate, and I would like to fasten mate this guy. So there's this. Now, if I did the top of this again, I would end up with that same problem. It turns out, though, I could actually reach down to the bottom of the cylinder and see how the axis is now going the other way. So if I did that and click it, they actually did the right thing. Little quirk of the program, when you mate two parts together, it will move the two parts together the way they're supposed to be. And if you think you like it, you can hit the solve button and it will fully resolve everything, and it will move all the other things with it. So if I hit the solve button, you'll watch this guy jump over here. Ready? 3, 2, 1, go. There we go. So now I have that full stack of things. All right. So that's pretty cool. Now I would like to fasten this bushing or spacer on the top of this. Now you need to be a little careful here when you're assembling things. It isn't always as straightforward as it seems, because if I zoom in on this edge, you can see that there is a chamfer here. So I need to be careful about what I'm selecting. Specifically, if I was to select this outer ring, that works. But let me close this real quick. So there's the outer, oh, let's see. Let me do that again. Fasten mate. If I hover over this and I hover over that, you can see that not only are the axes flipping, but they're actually moving. And that's because there's a distance between that and that, right? And so you want to be careful when you're selecting things and zooming in on stuff. So a lot of times, if I know that if I know what is going to touch, that's usually the correct thing to pick. So for example, I would like to touch this face, okay? That face right there is going to touch this face here. So I'm kind of ignoring the circles and I'm going with faces. And I can do that, okay? And I click that, and you can see that it mated the two faces. And of course, for whatever reason, I need to flip the axis. There we go. So now that moves up nicely, okay? And if I hit solve, it'll bring the other two bushings over with me. There they are. And that's what I wanted. And now if I come in and I zoom in on this thing, you can see that the faces are touching rather than messing around with those chamfers. And a lot of parts have chamfers on them. See, these have chamfers on them. And so you need to be a little bit careful with the geometries that you're picking to make sure that you're not picking a chamfer. All right. So now, why don't you go do that? See if you can get this whole stack together. Bushing, 3 shims. Go ahead. All right, welcome back. So now we would like to put this bushing over the top of the shaft here, and the face is going to actually ride on this face down here. See that face? Okay. And so that is going to be one edge of the fasten. Now the other edge is going to be the face of this. I'm going to click that. Okay. Now all kinds of things move just then, but that's okay. Now I can roll it back around and it looks right. I'm going to zoom in. I can see that I've got 3 shims and a bushing. That looks right. Okay. So this is good. Hit check mark. There you go. Go do that. I'll wait for you. All right. Welcome back. So, hopefully you got that. I was going to point out before I had you wander away, if you miss, there's all sorts of weird things for you to end up mating to down here. And again, if you screw up and mate to the wrong thing, you can always go back and edit it and remove the bad mate. Let's do one that's a little bit more complicated here. And that is, we want to mate this motor to the backside of this plate. And so how the heck do we do that? We have this really messy, there really isn't a circle anywhere. Well, it turns out there is. we're going to use the plane tricks, right? So it turns out that the top of these are all on the same plane if I look at them, right? So if I pick the plane of one of these things and I hold down the shift key, I can reach over here and pick that center point, okay? That is the center of the motor. You can kind of see it in there, associated with this plane, right? So I've got that. And now I want to go to the back side of my quad block here. And I'm going to select that center mark, which is associated with this plane, which is what I want. So, so I can actually click here and that should move into place. And you can see that those faces are now joined. Sorry, that wasn't a very good scroll. Here we go. So those faces now joined. And remember, it moved just the part that I was actually mating to, and it left behind the other parts. So if I hit solve, we'll get the bushing over here. There it is. And I should be able to hit the green check mark. All right, we just mounted our first motor. Very cool. Hey, we're going to put in some screws because if you do any CAD work with me, you'll find that I am a stickler for adding screws. They are super important, and screws will always be in your way if you're not verifying that they're right. So I've gone ahead and done an insert standard content. This time we're going to use a different kind of screw. So it's still going to be a socket head screw, and I'm going to click on component. And I would like to use a socket head or socket button head screw. The ISO 7380 is the standard number. You can ignore that for now. It's metric, and there's a whole standard behind these screws. It's all good. They're standard screws. Cool. I'm going to use M4s. And it turns out I need to know what length to use. For now, we're just going to use 8 millimeters. I'll show you how to measure things in a little bit. Okay, so we're going to go with 8 millimeters. So I want to insert one of those. Now, one of the more interesting things about this part is it's got some things for us to work around. That's why I love this part. So we're going to hit the green check marks because we've inserted a screw. I'm going to, I need 4 copies of that screw. So I've selected it. I've hit Control C, and now I'm going to hit Control V, and Control V. Okay. So I've made 4 copies of an 4 millimeter by 8 millimeter screw. All right. Remember how we used, we fastened this part to the top in the last video. So I should be able to look at it from the top here and see that the screw holes are actually associated with this, this arc here. So it's on this side because this is a slot. There's two arcs connected by a line that forms what's called a slot. So we're going to mate those. So we're going to do a fastened mate, and I can just grab the outside round or the rounded underside edge of this. Actually, sorry, unnecessary zooms here. There we go. I want to make sure that I'm picking that ring there, that face. And for the first one, let's just go over here and we're going to sneak up. If you want to grab a circular thing, you can sneak up on it and it will figure out what you want. See that? You can sneak up on this circle too, and it could put it over there. But I'm going to sneak up on this circle, and you can see that the target is in the center of the radius, and I can just going to left click once, and there I got my screw. Awesome, green check mark. I could also select that screw, and I could hover over the plane, hold down the shift key, come out and select the mate that was at the center, and that works. Okay, I'm going to do this one more time, but I'm going to make a mistake, intentionally make a mistake. I'm going to come over here. I'm going to hover over this, and I'm going to select this outside. Right, there's these 3 connectors. I'm going to pick the wrong one. I'm going to pick that one, and we'll just leave it there for now. And then this one, I'm just going to select over there. Okay, cool. Now, if I look at it from the top, you can see these are nice and regularly spaced, except this one, right? This one is off. It needs to move in a little bit. So I'm going to go back and I have to go edit it. So editing so to figure out which thing I need to edit, what are the mates on this thing? So I can actually highlight it, right click it, and do a show mates. And if I come over and look in mate features, you can see it is highlighted fastened 8. That is, and if there were multiple mates, that would happen. And I'll show you that in a sec. So that is the mate that I need to edit. So I'm going to double click it. I can see that I think the mate that we chose for the screw is fine. It was the mate connector on the plate that was bad. So I'm going to go and delete it. And then I'm going to come back down and I'm going to hover. And I'll zoom in a little bit here so you can see it. I'm going to hover. I'm going to hit the shift key and I'm going to select the mate that I actually wanted, which was this one. And see how it shifted it over? And I'm going to hit OK. All right. So now they are all uniform. So that's how, if you've screwed up and you need to find a mate, if you highlight a part and right click it, you can do a show mates and that will show the mates, right? So the other thing I can do is I can come over and I can right click this and I can say hide mates, and that will hide all of its mates. Okay. There's another kind of mate that we can get rid of, and that's this thing here. So if I hover over the automatic mate, I can right click it and see how it says hide all mate connectors. If I do that, all of those little mate connectors go away. So that's pretty handy. If there are multiples, things get a little bit more complicated, but when you're in a complicated assembly, sometimes this is useful. I can come over to this part and I can do a show mates, and you can see there's a lot of them. There's fastened to origin. That was the original mate. There's a fastened here, which appears to be so it is highlighting it. If I click on it, you can see the axes and stuff show up. And if I click off, it'll go away. This is highlighting the mates. So that's one way of identifying which one all these are. I kind of watch to see what's flashing. For example, mate, I've highlighted mate 8 over here. Okay. Take a look as I'm moving down the list, you can see it's highlighting the part. So see the screw is now its outer rim is highlighted. If I go down to number 9, watch how it changes. It moves over there. So that's kind of how you can find which of these, what parts these mates combine to. Okay. So hopefully that made some sense. And this is real useful if you're trying to figure out what mates are there. Okay. Very cool. Very cool. So now I can come over to this part, right click it, and I can say hide mates, and that will hide all of those mates again. We have one more thing to do for this subassembly and we'll be done with it. And that is to put on the bevel gear. So we're going to go, well, first of all, sorry, forgot to stop for you. Can you go do all of that? Can you make yours look like this? Go for it. Okay, you're back. We're going to do an insert. Other documents, we need to add the bevel gear. So I'm going to go to other documents. My library is still open. It always remembers the last thing you opened. So there are part studios and assemblies, okay? And so the bevel gear is actually in a part studio. Unfortunately, this is the one thing I really hate about Onshape is the composite parts, you have to explicitly know that they're there and select them, right? There are other parts in here, but you have to turn them on. They're called composite parts. If I click it, you'll see some bearings show up. In fact, here, I'll come down here. You can see them appear and disappear there. So these are parts that have what are called multiple bodies. And we won't get into that too far, but suffice it to say that a lot, if you can't find something, check to make sure that composite parts is turned on. Okay. We're looking for this bevel gear. Here it is. I'm going to put that right here and we'll just left click it. And so we inserted it. Okay. This guy is going to go on the shaft. It's actually a hex shaft, so it'll fit on the hex shaft. We're not going to be too religious about the hex shafts for now. It's a little bit more of an advanced topic. I'll show that to you later. But I would like to place this gear onto our shaft, and I want it to ride on this surface here. So I need to think a little bit. If I was to take this this gear and plop it on top there, what's going to touch? What are the mating surfaces? Okay. Well, I think it's going to be the top of the shoulder of the spacer. And what's right next to the shaft? Well, it's this indent over here. So I wouldn't pick this. I need to pick that inset, right? That indent. So that's where we're going to mate. And so we are going to do a fastened mate on this, and you can see it. I've highlighted that surface, and I want it to pick the center. I may need to hit the shift key. I hit the shift key. There we go. So the center of that surface is going to mate to this surface. All right. And of course you have to flip it, because why not? All right. Hit the solve button. There it is. That's what a gear looks like mounted to our thing. And we're almost done here. A couple things I still want to do.
So a useful thing for our models would be for this gear to be able to turn. And it does actually turn. So that's pretty convenient for us. Now, this is going to be in a subassembly, and that subassembly is going to be used in other places. The revolute that actually is making this turn is actually hidden way down inside the yellow jacket. In fact, I can go find that, the yellow jacket. And if I look at its output shaft, if I come all the way down here to its mates, you can find the shaft rotation mate. So it's got a name. It's a revolute mate, and it's way down buried inside the motor. So that's not very convenient for us, because if we want to just use this module over and over again, it'd be a lot more convenient to have a mate that is more accessible. So that's what we're going to do right now. And so this is foreboding, because I know that we're going to want to access that revolute mate later. We can actually establish another revolute mate all the way up here and make that work. So what we're going to do is we're going to do not a revolute mate, we're actually going to do a cylindrical mate. A cylindrical mate is treated like a revolute mate. It has a rotation around the z-axis. And so what we're going to do is we're going to have a revolute mate assigned to the bevel gear. So I'm just going to click I've highlighted the top of the bevel gear. I'm going to click on the center of it. And then I'm going to, if you'll remember from revolute mates, the first selection is the rotational point and the second is the stationary point. It kind of is actually the same rule with the cylindrical mate. It uses the first selection serves as the transitional and rotational point. The second is the stationary point. And I am going to select the center of a fixed point, which is going to be our motor mount down here. And so I'm going to sneak up on there and make a cylindrical mate here. If I solve that, it should show up nicely. Okay, so there we go. And I'm going to close this real quick. I want to be able to find that one, and I'm going to call it a revolute mate, even though it really isn't, but it is rotational. So I am going to rename this cylindrical mate, and we're going to call it the bevel gear revolute, and that mate will be accessible to us without having to dig down into a whole bunch of subassemblies. Now, why did I do that? Little foreboding, little foreshadowing. I've done these sort of mechanisms before. It turns out being able to access that by name is going to make life a lot easier. You'll see the results of that coming up soon.
Okay, what do we have here? We have ourselves a mounted motor, a motor mounted on a quad block with a bevel gear on it. Yay. And we're going to use this multiple times. So we're going to make this is now a subassembly This is no longer going to be our main assembly. We're going to use this over and over. So I'm going to rename this to something intelligible. How about mounted motor bevel gear? All right. You can use your navigation thing to move around. I did want to show you a couple of other real quick things. Hey, what if I wanted to see what was under this bevel gear because it's sort of blocking things? There's some tricks that you can play. One of them is to actually just take apart like that bevel gear, right click it, and I can make it transparent with that little button right there. And see that? Now I can see under it. I can actually access things under it. Now, transparent things are, they're there, but you can't interact with them because they're transparent. So if you're trying to sneak in and mate something or do something underneath something, it's a pretty good trick. I can also click on this part and make it transparent. Okay. And so now I can see, I still have a hint that it's there, but I can see everything under there, and I can reference and touch things without those parts being in the way. It's a really useful thing to do. Huh? All right. So I'm going to cancel transparency. You just sort of close this make transparent dialog and they'll come right back. I think that's pretty cool. Hey, here's another interesting thing you can do. You can actually, in this cube over here, there are a bunch of different rendering options that you can do. The default is called shaded, and shaded does what you're seeing right there. I'm going to switch it to shaded without edges, and you'll notice the appearance change just a little bit. Ready? Okay, it changed a little bit, and the reason is that by default, the shading will give you hard edges on everything. Let me go put it back on shaded. See how there's lines? Shaded without edges is, in theory, more photorealistic, I guess, because that could be the case. All right. So now the other thing you can do, depending on your computer, this may slow it down or speed it up, is you can do view in high quality, and it's telling you that its performance can decrease. It's really not going to matter on my computer. It has a very large graphics card in it. But if you're finding that your computer is way too slow as you're rotating things, try disabling high quality if it's on. Okay. The other thing you can do is you can get out of shading and just do with hidden edges removed. This gives you just a line drawing. So it's not spending all of the graphics processor power needed to do all of the photorealistic shading. If you're on a smaller computer, this could actually speed up your life quite a bit. It's not quite as sexy to use, but that's okay. All of the details are still there. Okay. Some other things you can do is you can actually do with hidden edges visible. And this starts to get a little messy, but there are times that you want to do this. If I click hidden edges visible, they're back there. You can't really see them, but this will allow you to, zoom in and realize that, down this hole, there are a bunch of threads. There are things on the inside that you need to wonder about, right? There may be screws, right? Let me move this up. So here you can see the screw that's in there, right? Normally you wouldn't be able to see those because those are considered hidden edges, but you can't actually interact with a whole lot with the hidden edges. I think, well, you can. Let me take that back. You can interact with those hidden edges. Yes. Okay. Another option is, well, I'm going to skip tangent edges for now. You can also make the whole thing translucent, and there are interesting reasons to do this. The reality is that I don't really use this that often, but sometimes, especially if I have a very complicated mechanism, it turns off all of the surface shading, leaves all the lines, but it can be again a useful view if you're trying to access something internal. Like say I actually wanted to look at I wanted to do something with the edge of the bushing, for example. There's that spacer that we put on earlier. With translucent, I can kind of reach in there and see things. So useful, not quite sure. Okay, I'm gonna go back to shaded over here. There are some other things that you can do with this little this camera and render options. You can zoom to fit. That will fit everything onto the screen. So if you're way zoomed in or you can't find your parts, that sometimes happens. Sometimes just doing a zoom to fit is an awesome idea. You can zoom to selection. So if I do zoom to selection, it will zoom in on the thing that I've got selected there. If I unselect, let me select this thing, right? And let's say it's way over there. If I do a zoom to selection, it'll zoom in and show me the thing that I've got selected full screen. That's useful a lot of times. If you're zoomed way in like this, and you want to get back to fit everything into the window, if you take your scroll wheel, mouse wheel, and double click it, click, that is pretty much the same as zoom to fit. And so that will get you right out there. Hey, there's a couple of other perspective things that if you turn them on, you may get confused about what the heck happened. All right, let me show you. If I do turn perspective on, the motor will get distorted. See that? So that, things that are closer are bigger, things that are farther away are smaller. And this is actually how your eye works, but it's really hard to do CAD this way. So if you've accidentally turned that on and you're getting this weird thing, check to see if turn perspective is off. You want to turn perspective off. There you go. So perspective distorts angles, and right angles are no longer specifically right angles, and it's hard to work in. Okay, there you go. There's one other sort of an odd. We'll deal with section views later. There is a thing called a section view. Well, here, I'll just show it to you real quick. What if I wanted to see a cross-sectional view of this motor? And let's say I'm going to use this face as the cutting edge, okay? This is actually pretty cool. If you come down and you do section view, it's asking you for a plane. And so that plane, you can pick any plane. We're going to select the back end of this motor here, and watch what happens. It sliced off, the motor, right? Now the motor doesn't have all the windings and stuff in it, but this can be particularly useful if you're dealing with an entire robot and you need to work on something that's on the inside. For example, let me bring over the finished robot here. Let's say that from the right side, I want to do something with the end of this part over here. I want to mess around, but all of this stuff is in the way. I can actually do a section view, and I can pick a cutting edge, and I'm going to pick that edge right there, which is the edge of the arm. Okay. Now, when I look at it from the right, you'll notice that it lopped off that whole outside rail, but I have access to all of the internal parts in here, right? So that's pretty interesting. And it turns out you can actually have multiple sections. So if I wanted to, I could also pick, say, that plane right there. And what it did is it cut it cut the wheel in half, right? But it allows you to get access to things that you may not be able to otherwise access easily in the CAD. So it's a useful thing. And you can edit the section views up here by removing things, right? And you can cancel the section view, and that will put everything back. You're not affecting anything, you're just affecting the view of it, okay? So that is what this little camera and render options can do for you. So over here, I'm going to cancel my section view. There we go. It will remember your section view, by the way, I believe. Oh, no, it didn't remember it. Here we go. If I hit the green check mark, and that's my section view, I can turn it on and off. I can turn section view off, and I can turn it back on again. Okay, it'll remember it. So there you go. So in our next video, we are going to finish building this part of the robot, which is the robot base. So we're going to make a couple of sub-assemblies for the
we'll make sub-assemblies for the cross members, we'll make side rails, and then I'll show you how to make a slightly more complicated set of sub-assemblies to handle the bevel gears and the wheels, and we'll make everything work together. So we will see you with the next one.